Hey, welcome! Today, we're going to talk about an invisible force, one that can literally make or break a multi-million-dollar construction project. It's a silent variable, hiding right under our feet, that every single architect and engineer has to respect.
So let's just jump right in with a question for you. What is this hidden force? I mean, what could possibly have the power to complicate every single decision, blow up the budget, and dictate the very foundation of a building, all before anyone even breaks ground?
And here's the thing. It's not some mistake in the blueprints or a screw-up by the construction crew. Nope. It's a fundamental condition of the site itself, an underground reality you just can't ignore. The answer, it turns out, is something called a high water table. And you got to understand this, because when that water is close to the surface, it changes absolutely everything about how you're going to build. Okay, so what in the world is a water table? Now, you might be thinking it's like some secret underground river or a hidden lake, right? But it's not. It's actually something much more basic, baked right into the soil. So let's break this down.
So the textbook definition is right here, but let's make it simple. The water table is basically the line in the dirt where the ground goes from being just damp to being completely 100% soaked with water. You know when you dig a hole at the beach and it starts to fill with water? That's it. You've found the water table.
This really paints a picture of two totally different worlds right under your feet. Above that water table line, you've got the unsaturated zone. Think of it as soil with some air pockets and a bit of moisture. It's where we build our basements and foundations. But once you cross that line, you're in the saturated zone. Every single tiny space between dirt particles is filled with water. It's a whole other ballgame down there.
Okay, so we get what it is. Now for the big question. Why is a high water table, one that's just a few feet down, such a nightmare for construction projects?
Oh, it complicates everything. All of a sudden, that simple basement you planned needs a crazy expensive waterproofing and pump system. Your budget? It just explodes, because now you're paying to constantly pump water out of a giant mud pit, just so people can work. And maybe the worst part? Those standard, affordable foundations you were counting on? Yeah, they might be totally off the table. All right, let's make this real. Imagine you're the architect. You get the site report back, and boom, the water table is only 4 feet below the surface, but your design calls for a 10-foot deep basement. What does that mean for your plans, like right now?
Well, that's the heart of the issue, isn't it? You can't just dig a hole anymore. You're basically trying to build a basement in the middle of a swimming pool. So you have to engineer these really intense, heavy-duty drainage and waterproofing systems. And that, my friends, is a direct, painful hit to the budget.
But hey, it's not all doom and gloom. Engineers are smart, right? They've been tackling this exact problem for centuries. A high water table isn't a project killer. It just means you have to get a little more clever and usually a lot deeper.
So here's the bottom line. Your normal, everyday shallow foundations, things like simple concrete footings, are just not going to work. They'd be sitting in water, which makes them unstable. They just can't do their one job, which is to safely hold up the building. So what's the solution? You basically have to bypass all that soggy, useless soil. You have to go deep. We're talking about using things like piles or caissons. These are basically giant, powerful columns that get drilled or hammered way, way down into the earth until they hit solid ground or bedrock, far below all that water.
So that leads us to a pretty straightforward question. What are the go-to foundation systems for a site with a high water table?
You got it. Piles and caissons. These are the heavy hitters. They're the engineering answer for how you build something massive and permanent on ground that's basically a sponge.
But it's not just about going deep. It's really a 3-step battle plan. First, you pick your weapon, the right deep foundations. Second, you set up your defenses, aggressive drainage systems, things like French drains and sump pumps to get water away. And third, you put up a shield, special waterproofing, like these cool bentonite sheets that actually swell up with water to form a perfect impenetrable seal.
Okay, let's pull all this together. We've talked about the problem, what happens if you ignore it, and the smart ways to fix it. So let's look at the final blueprint for how to think about all this.
But let's flip the script for a second. What if that site report comes back with great news? What if the water table is way down, say 20 feet below ground? Well, that changes the game completely.
Yeah. In that case, you can breathe a sigh of relief. Those simpler, way cheaper, shallow foundations are back in play. Because when the water is that deep, it's just not a threat. It's out of the way, and you can go with the most affordable, common sense option.
So, what's the big takeaway here? It's this: that one little number on the soil report, the depth of the water table, isn't just a boring piece of data. No way. It is one of the most critical factors there is. It directly impacts the design, the schedule, and maybe most importantly, the final cost of the entire project.
So, next time you're walking through a city and you see a massive skyscraper reaching for the clouds, just take a second. Think about what's going on beneath your feet, and maybe you'll wonder, what incredible, unseen engineering is down there, silently fighting back against the constant pressure of all that underground water?